Stacks and queues are simple data structures that store elements in the order in which they were inserted. Java has built-in classes to represent both stacks and queues. First, let's look at stacks. The stack class contains these basic operations. So first we can construct a stack. Notice the type parameter. We have to specify what kind of elements can be stored in a stack. Any object type will do. Adding and removing elements are done with the methods push and pop. When we pop a value from the top of the stack, we remove it. We can peek at the top value of the stack without removing it, too. Finally, we have the size method that says how many elements are in the stack, and isEmpty tells us whether or not there are any elements in the stack. Here's an example of a stack of strings that stores various names. When we call the pop method on the stack, we get the topmost name, or the last inserted name, which is Jane in this case. Let's look at an example. I have a simple class here with a main method and a max method, which we'll look at a little later. Let me create a stack to store numbers. So here I can create a stack and use the integer type as my type parameter. Notice I've already imported from java.util. That's where the stack class is stored. So I'll create a new stack, and I need to use the type parameter when I call the constructor as well. And so this has created a new empty stack. Now I can start adding elements to my stack by calling the push method. So I can push 42 onto the stack, and now this is both the top and the bottom of the stack. When I push something new onto the stack, say 23, now 42 is the bottom of the stack and 23 is at the top. I can push a couple more elements in. Let's add a 5 and a 43. Okay. A stack does have a toString method, so I can go ahead and print out the stack to see what's in it. And so here we get a nice representation of the stack. 42 is at the bottom, 43 is at the top. If I want to pop a value off the stack, that's going to come from the top, and so that will give me the last inserted value, which in this case is 43. Now, let's say we want to print each of these values in the stack on a separate line. We'll have to do a stack traversal. When we did traversals of lists, so array lists or arrays, we used for loops to access each index in the list. Now stacks don't have indexes, so we're going to have to use a different strategy. When we traverse a stack, we use a while loop, and we test to see whether there are still elements in the list. So a stack traversal will look like this. We have a while loop, and while my stack is not empty, what we want to do then is examine each element and do something with it. So we'll often have a call on s.pop in that traversal. So in this case, we just want to take each element and print it on a separate line. So notice that this did what we wanted, and also it reversed the order of the elements. So 42 was the first element we put in. It was the last element to be printed. 43 was the very last element to be added. That's the first element to come out of the stack. So stacks reverse the order of its elements, or can be used to reverse the order of their elements. Now let's take a look at this max method. So you can see we have another traversal here. Our goal is to find the biggest element in the stack. We take in a stack of integers as a parameter. So in our traversal, we take each element and we compare it to a max value, which we had set to be the first element in the stack. Then we return the maximum value. So let's go ahead and try this method out. So I can call it by calling max of s. Of course, if I want to see the result, I better put that in a println statement. And so let's make sure this works. I think the biggest element in our list now should be 43. So here we go. Max is 43, just like we expected. But wait a minute, there's something missing here. We were supposed to still traverse our stack and print each element on a separate line. There's nothing down here. So what happened? Well, as we were calculating our maximum, we actually lost all the values in the stack. So a stack traversal is destructive. We've popped off each element from the stack. So how do we fix this? Well, a common fix would be to store all the elements in another stack as we go through the stack. So here's what that would look like. I can create a stack of integer. That will be my backup. And that'll be a new stack of integer. So I have a brand new empty stack, and now each time I pop something off my original stack, I want to make sure to save it for later. So instead of just discarding it, I want to save it into this backup stack. So I can say backup.push max value, because that's the element that I just popped off of S. Now here again, I pop a value off of S so I can push it onto my backup stack. So there we go. So that's great. Now I've saved every element from the original stack, but now they're in this other stack I've created instead of being in S, which I used up here. So if I run this code, I still have the same problem. Even though the values were saved, they were only saved in the method down here. So before I finish, I have to make sure I copy things back into the original stack. To do that, I need to traverse my backup stack and take each element out of the backup stack into S. So to traverse the backup stack, I have a while loop, and I'm testing to see whether or not my backup is empty. So while I still have some values in my backup stack, I want to take the value out of backup and put it into S. So in one line it looks like this. I'm going to say I want to push something onto S, and what do I want to push? Well, whatever is currently at the top of backup. So I'm going to pop the value off of backup and push it onto S. And so we've traversed the entirety of backup and put things back into our original stack. Let's take a look. So we have our 43 here, which is our column max. That's still correct. And here we have each element in the stack printed in reverse order from which they were added. So we've successfully put our values back into our original stack. So in summary, when we traverse over a stack, we're actually removing each of the elements using pop, and so we have to be careful if we want to ever use our stack again to put elements back into the stack.